So I'm just going to talk about 13 because you can use really the very same strategy for 14 and 15 as well. So when we want to solve for t, what we're saying is let's get t by itself. But the problem here is that we have 3 terms that have t as part of that term. So here's what I want to do. I want to get all, just like I would if I were solving an equation, I want to get all of the terms that have t in them on the same side of the equation. Okay, so let me go ahead and add 6t to both sides. So what I do then is I've got MP equals, so I have 3yt plus 5qt, haha, cutie, plus 6t. Now, guys, if we were solving an equation, let's say it looked like this, okay? So let me give you kind of an aside here. Let's say we had something like 10 equals 2x plus 5x minus, let's not do minus, let's do minus 4x. So we know that we would then add those together and we would get what? Negative, so we'd have 7 minus 4, so we have 3x, okay? We know that. But what we don't know in this problem that we're doing is the value of y, q. We just don't know the values of those. So we can't combine these in a way that gives us one term. So I want to think about, what's another way we could have approached the problem on the right? And what I could do there is I could say, you know what? Every one of these terms has an x. Okay, so what if, just play along for a second, what if I did this? What if I factor out an x out of every one of those terms? In other words, I divide every term by x and I write that thing that I divided by out in front as its own factor. So then what would be left is 2 plus 5 minus 4. So then what we have is 10 equals x times, well, there's that 3 we were expecting. So really, we get the same thing here. We get 3 times x. And then we would divide both sides by 3. Now, if we go back just a second here, instead of dividing by 3, we could divide both sides by just that entire sum. So I really could say, let's divide both sides by this. Right? Because I know that that's going to be 3. But it's just another way to write 3. So then x in this case would just be 10 divided by 2 plus 5 minus 4. That's one way we could write x. Now what I also know is that this ends up just being 3, which is a lot simpler. So we're going to use that same approach here. So what I see here is that every one of these terms includes a t, right? We did that on purpose. We gathered up all of the terms that have the variable that we're trying to isolate. We put all those terms on the same side. So let me rewrite this so that we factor out the t. Okay, remember that just means I'm dividing every term by t and writing what would be left. So if I divide 3yt by t, that's just going to be 3y. If I divide 5qt by t, that's just going to be 5q. And if I divide 6t by t, that's just going to be 6. So now, just like we did in the previous example, I can say if I want to get t by itself, all I have to do is divide both sides by 3y plus 5q plus 6. And then I get an expression for t. And that expression is mp over 3y plus 5q plus 6. All right. So like I said, I don't want to go into the other 2 examples. Or the other 2 problems. I want you to see if you can use this approach now to actually finish solving those.